All right, let's go ahead and get into today's topic, which is a new data type or a new variable type, and that is a list. In Python, there are 4 or 5 different types of lists, depending on how you want to look at it. Those lists are each one is a little bit different. Today, we're going to talk about 2 of those. And technically speaking, the first of the 2 type is just usually referred to as a generic list in Python. So if you hear me just say list, or if you hear me say the word array, that's what I'm talking about, is just the generic list type. The second type that we're going to talk about today is a dictionary. And those 2 are by far the most frequently used in Python. And they're the most frequently used in this class as well. We will cover the other types, but we're just going to ease into this because it's a lot of information. And I'm going to introduce lots and lots of functions today, but don't worry, there's a reference page where you can go back and look at those. So lists, also known as arrays. In fact, in most other languages, lists are actually referred to as arrays. And they basically mean the same thing in Python. But what it allows you to do is to store multiple objects or multiple values in a single variable. And this makes a lot of sense for grouping data, for organization purposes, and it allows you to create what are called data structures, which are sort of a fundamental concept in any programming languages, but especially in Python where we deal with a lot of data. So if I'm going to create an array or a list, I'm going to use an appropriate variable type that lets me know what it is. So I use ARR at the beginning because in my mind, I'm used to saying the word array for things like this. You could use LIS or whatever makes sense to you. Primarily, it's just a matter of getting into the practice of naming variables based on what they are. So I have ARR pets and the equal sign, of course. And then in square brackets, the brackets are important. So square brackets, I have 4 strings separated by commas. And so that is an array of different types of pets. And all of those information, all of the pieces of that information are grouped together in that single variable. Now, I could use any type of data or any object in place of these. So I could use an integer, I could use a float, I could even use another object or even another array. I can have an array of arrays. And you can go so deep in terms of levels of arrays inside of arrays that you'll confuse yourself. You don't want to do too much of that, but it's not uncommon to go 2 or 3 levels deep. So you have what's called a multi-dimensional array. We're not going to do that yet.
So when you do a multi-dimensional, do you put multiple brackets, or do you just
You can do it that way, but sometimes it's easier to define this array and then put it inside another array. So instead of this, you might have a variable that represents an array when you build it.
So you put the variable inside the array, so it just stacks inside.
Yeah, it's a little easier to understand it that way. If you put the brackets inside the brackets, it gets really messy really quickly, and you're going to just blow a fuse. So the things that are particular to arrays, okay, they're ordered, which means dog is always going to be first in this array, unless I explicitly change the order of things, which I can sort this or reverse the order or do all kinds of things with functions. But unless I change this, that order is always going to be the same. It's going to be dog, cat, fish, bird. I can rely on that because it's indexed, which means each one of these has a number that is associated with the slot that data is in. So in slot number 1, this is an important thing to remember, so always stick this in your head. The number for slot number 1 is 0. We start counting at 0. So this array has what we call 4 members or 4 pieces of data. 0, 1, 2, 3. Okay? Always 0 first in an array. Sorry, that's just a computer science thing. It has to do with memory addressing. If you're curious, it has to do with memory addressing because this one would start at 0. It would go from 0 to 1. It would occupy that spot. This one goes from 1 to 2. So the address of this is 0. That's why. So they're ordered, they're indexed, they're mutable. So a list, I can change it. I can change the order of the indexing. I can delete members. I can add members. I can do all kinds of things. I could change cat to an object if I wanted to, or a number, or whatever. It's mutable, which means it's changeable. Just like think Mutant Ninja Turtles when if you want to remember what mutable means. So any object can fit in this. It's not just strings and numbers and basic variable types. I can literally put an entire class in here. I can put any type of variable, like I said, including other arrays. So they're extremely flexible, which makes them really powerful. Now, a dictionary has some similar things in that they're ordered and they're mutable and they can contain any object. But if you look at how a dictionary looks, there are some difference. I have dictionary employee here is the variable name, equals. Instead of brackets, instead of the square brackets, I have curly braces. This indicates that it's a dictionary rather than a list. Okay. Also, you can see that I have name colon Bob, age colon 25, job colon developer. So rather than 0, 1, 2, 3, 4, I have what are called key indexes. This one, if I go DICT employee slot 1, it's going to throw an error because there is no slot 1. I've named indexes rather than numerical. The nice thing about this is that in my code, it's a lot more readable. It makes a lot more sense because you might not always remember what's in slot 1. But if I say DICT employee and then in brackets I say name, you'll know exactly what you're getting at because you're looking at an employee name. So semantically, it's a lot easier to read. And normally, I would declare it like this. I just did it this way so you could see the key and value pairs. So this is the key, value, key, value, key, value. I can add keys. I can delete keys. I can change the value. So I could say DICT employee age is 36 if I wanted to. So it's extremely flexible, but also pretty powerful because, again, ordered, mutable, and any object. I could literally put dictionary employee kids, and kids could be an array of the names of their kids, or a dictionary with the kids' names and ages. So there's tons of things you can do with this. Lots of flexibility, very powerful. You're going to start seeing how powerful these are as we start getting into programming with them. So I'm going to flip back and forth between dictionary and list because I want you to see the comparison between the two. So when I access the values of a list, I have ARR fruit, which is an array of fruit, apple, orange, and banana. Again, 0, 1, and 2. And then in that list, I've got the ability to access that value and assign it to, if I wanted to assign it to a string variable, I would say strval, or string value, equals array fruit, and in square brackets, the number 1, which would pull orange. So now strval is equal to orange, just a normal string, because I've taken that value and I've put it in that variable. So I've taken it out of one container, put it in another. You can think of an array sort of like a bento box, right? It's got all the little compartments, and each compartment has a number. So I'm taking the orange out of that one, and I'm putting it into another container. And of course, I can just print it like that. Now, I could print the string variable, but I could also just say print and then put this inside the print function. It would work just fine.
So
Yeah.
when you're doing that, you're assigning strval to ARR fruit. So when you print strval, it's going to print everything inside of ARR fruit.
No, I'm assigning ARR fruit slot number 1.
Oh, okay.
I'm putting this in here. So I'm putting orange in here. So strval equals orange, and then I'm just printing orange. I could do that though. I could say strval equals ARR fruit and leave off the number, and then it just makes a copy of that array. And it actually makes a reference to that array. If you want to make a copy of an array, you want to do it differently, because if I do this and then I make a change here, it'll make a change to that because it's making a reference. It doesn't seem like it should be that way, but it is. So strval at this point equals orange. So if I want to access the value of a dictionary object, rather than using the numbered index, I'm going to use the key value. So it would look like this. If I wanted to print the value of dictionary employee name, which in this case, I'm going to print the word Bob, okay? I have dict employee, and notice I'm not using curly braces when I access the value, just when I create the dictionary. So I create the dictionary using the curly braces, but when I want to access a value, I'm using the square brackets with a quote, because this is a string. So it has to be a string here. If I don't have quotes here, it's going to look for a variable with name that would indicate which string. So it gets confusing, but make sure you're using a string inside the square brackets to indicate the key that you're using. There's another way with dictionary. There's a function called get. I don't know a good reason to use get over this method, but either one will work. Notice with get, it's a function, so we're using parentheses.
So they all have single quotes, right? So when you're
Single or double are interchangeable almost throughout Python. In this case, I just chose to use single. A little bit random. But you can see here I'm using doubles. So double or single, they're always interchangeable. So setting a value or changing a value, if I wanted to change the number 2 slot, which is the third element in that array, to watermelon, I would use this. And then the new array looks like this, where it has watermelon in that spot. So it'll replace whatever's in that spot with this. If this spot doesn't exist, then you probably create a spot and put that in there. Okay, but that's not the way you should add elements. If you want to add an element to the end, there's a better way to do it. So dictionary employee, if I wanted to change the name or whatever's in the slot with the key name, I would do this syntax and then equals Bill. So I'm basically saying in that pocket of that bento box that's labeled with name, you're going to put that value. Okay, so the new dictionary object, if I printed it out, would look like that. Okay, so when I want to remove a value, there are two different ways. They're kind of the same. They're very similar between the two, list and dictionary. One of them, pop, actually takes the value out of the list, so it removes it. It's no longer in the list, and returns it. So you can assign it to a variable, or you could print it, or you could do something with it. So it does two things. It takes it out of the list and puts it in the variable. The delete or del command will just take it out and throw it away. So it depends whether you use pop or delete, kind of depends usually on whether you want to do something with the value that you take out of the list or whether you just want to toss it away. You could use pop and not assign it to a variable if you wanted to, and it has the same effect as delete. So a lot of people just use pop for everything, and then if they want to keep that value, they put it into a variable. Same with dictionary, except instead of using the index, we're using the key value for those, but it is the same syntax and the same way of doing things. Okay, so adding values, the best way to add to a list is to use the append. This adds this value to the very end of the list. No matter how long the list is, you don't even need to know. This just says put that on the end. So dictionary, because a dictionary isn't as tightly ordered and it doesn't have a numeric index, you have to specify the key that you're going to put that in. So you always need to specify the key when you're using a dictionary by name. Okay, so now we're going to get into a long list of functions, and these are all list functions specifically. And if you go into module 7, you can see those functions are right here. And I wanted to point that out, that there's a link to that from Canvas, because you're going to want to refer to this. So the same screens that I'm showing right now in class are all right here with examples of how it's used and details on the parameters. So as we go through these, I'm going to go kind of fast because I just want you to get a feel for what they are. And then I've got a sandbox challenge for you that's going to require you to use these things so that you can get practice with how they work. So append, we just talked about, is what you would use to add an element to the end of a list. You could append a list on another list if you want to. So in this example, you've got a list of fruits and a list of car makes. And what we're doing is appending B to the end of A on that. Or you could append an object or anything else to the end of a list. Because remember, a list can be a mix of different things. Clear is a function that just deletes all of the elements of the list. It doesn't delete the variable, so the list is still there. Python still thinks of it as a list variable, but it now has no elements. It has no data. So it's just an empty list with 0 members. Yeah. Clear, you might use, like if you've got a program where over the course of running the program, it adds to a list, and then like you want to restart the program or reinitialize the program, then you'd clear the list and you'd have a fresh whatever at the beginning. So that's a possible use case for that. Copy, just like it says, it copies another list. So you supply the variable that list gets copied into. Copy is better than just saying x equals fruits, because copy actually creates a duplicate copy that's no longer connected. If you just say x equals fruits, anything you do to x also gets done to fruits. And the problem with that is that you could change your original array without realizing what you're doing. So you always want to use copy to make a copy of a list. Count will let you know how many elements inside a list match a certain value. So if I have fruits, and in that fruits I have apple, banana, and cherry, and I say fruits.count cherry, it will tell me 1 because there's 1 instance of cherry. If there was 16, it would return 16. This is really useful for processing really long lists or lists with hundreds or even thousands of values in them, which is a lot more common than you think. Extend works with 2 lists exactly the same way that append does when you append one list onto another. This will just create or take one array and add it to the other. Combine the 2 basically, but one after the other. Index will give you the first occurrence of the specified value. So again, if I'm using the apple, banana, cherry, and I index cherry, remember count tells me how many times cherry appears in that list. Index tells me what position it appears in first. So 0, 1, 2, it would return a 2 if I indexed cherry. And it just gives you the first one. That's useful if you want to do something like pop, because pop requires you to supply an index. So if you wanted to find cherry and then pop it into a variable, you could do that. Index or insert allows you, it's like append, but it allows you to specify a position inside the list if you wanted to insert it in the middle of the list instead of at the end. So that, again, if you want to put it at the beginning of the list, you would use 0 because that's the first position. Okay, pop we talked about. Remove is similar to delete. It does not return a value, but it removes it based on the value, not the index. So pop and delete use the index. This uses the value. So if I wanted to remove banana, it's just going to remove the first occurrence of banana in that list.
Not any other one, just the very first one it encounters in the list, right?
Correct. Yeah. So you'd have to run it until it stops, basically. Um, reverse reverses the order of the list, so it flips the index backwards. Sort is a little bit more complicated than reverse. Reverse just flips the index. This actually allows you to sort things by value. So for example, I could alphabetize this list of cars using sort, and it would go BMW, Ford, and then Volvo. I can also sort them in reverse order. Okay, notice that this has a reverse equals true or false optional parameter. So if I say reverse equals true, then I can do things in reverse alphabetical order. If my list is numbers, it will sort them into numeric order. A more advanced feature is this key here allows you to supply a function that will allow you to do things like, let's say, sort a list of words by the length of the word, or by the frequency of the letter W in the word, or whatever factor you want to sort by. So you can go do some really advanced sorting with that. We won't get that deep into that command in this class, but it is there in case you want it. So Sandbox for challenge 7. This code is already on the website under Sandbox 7 for you to download. And what you'll see here is that the very top line is a list of words. Those words form a quote by somebody famous. It's one of my favorite quotes, actually. And if you follow the steps 1 through 15, and you do them properly, it will change these words into the actual quote that you can then print out. So the way I would recommend using this file is I would download the file, and then for each step, I'd make a space there, and I would just do that command. So the first one, AR quote, sort, and then you might just, you could put a print statement down here at the very bottom, but I kind of like to see it print each time I make a change. So if I do this and then I run that, let me print it before we start so we can see AR quote. Okay, so the first line, this is with no changes, just like that, prints it out. Now I've alphabetized it, so I sorted it. That was step number 1. Step number 2 is to use pop to remove the third element. So I'm going to say AR quote dot pop third element, which is actually number 2. And then I'm going to print it again so I can see the change. Okay, so there we go. So I alphabetize them, and then I remove the word change. I printed it again. So if you go through all of these and you follow the instructions correctly, then you will end up with a quote that makes sense, and you probably know once you hit it, you'll see the quote, and you may even recognize it, depending on who you read, I guess. But yeah, so that is the assignment. Or that's not an assignment, it's actually a sandbox. But if you do this and you go through each of the steps and you use this list of Python methods to help you understand how to use each of those methods, then the Python list methods then you have a pretty good idea of how to use some of these things. And when we get to the assignment for Wednesday, you'll have a pretty good understanding of how to do it. So that's it for today. Encourage you to spend some time working on this. And although it's not due for any credit, I think it's useful. So let me know if you have any questions, but I'm going to give you some time to work now.